In this lecture, I will share Cartesian coordinate system. First of all, the question is, what is the meaning of this Cartesian coordinate system? It is a frame of reference. Frame of reference to decide location of an object. Suppose an object is moving in the space, we have to decide where it is. We have to use some system. That system is known as Cartesian coordinate system. Now let us try to understand the meaning of Cartesian coordinate system. In this system, we have three mutually perpendicular axes. One axis, this one, second is this one. Both are lying in this plane, and the third axis is perpendicular to both these. This pen is representing the third axis, but it is not possible to show it here. So I show this axis as with the help of some inclined line. This axis, let me call it x-axis, and this axis it known as y-axis, and this one as z-axis. All these three are perpendicular to each other. X-axis is perpendicular to y-axis, y is perpendicular to z-axis, and z is perpendicular to axis. The meeting point of all the three axes is called origin of the system. So this angle is of 90 degree, this angle is also 90 degree, this angle is also 90 degree. This is called Cartesian coordinate system. Now the next question is how to locate the position of an object. Suppose this is a point P that is in space. We have to find its coordinates. Let me call the coordinates as x, y, and z. Now what is the meaning of x coordinate, y coordinate, and z coordinate? What will I do? I will draw a perpendicular from point P onto xy plane, the plane containing x-axis and y-axis. Suppose foot of the perpendicular is Q. Now from this foot of perpendicular, I will draw a perpendicular on y-axis as well as on x-axis. Let us call this point as A. Here angle is 90 degree. Here also angle is 90 degree. Let me call this point B. So this distance OA is called x coordinate of the object at point P. Similarly, distance parallel to y-axis OB is called y coordinate of point P. Now how to find z coordinate? For this purpose, I will draw a perpendicular directly from point P onto the z-axis. This perpendicular, suppose it falls on z-axis at point C. So the distance from O to C is nothing but the third z coordinate of point P. This is how we can define in this system x, y, z, three coordinates of point P. When point P moves, all the three coordinates may change. If I join origin to this foot of perpendicular Q, this line will be parallel to this perpendicular PC. Next, I want to share that if a body moves in such a way that only one coordinate changes, other two remain same, then the motion of the body is said to be motion in one dimension. So motion in one dimension means when only one coordinate changes. When only one coordinate. It may be x coordinate, it may be y, it may be z. When one coordinate changes. For example, when a body moves in a straight line, that is motion in a straight line can be called as motion in one dimension. Similarly, what is the meaning of motion in two dimensions? Motion in two dimension means when any two coordinates change. Any two coordinates change with the motion of the body, then the motion is said to be motion in two dimension. In this case, motion in two dimension, the body will move in a plane. When a body moves in a plane surface, suppose it moves in xy plane, then its x coordinate and y coordinate will change, z will remain constant. Similarly, if it moves in yz plane, then x will remain constant, y and z will change, and so on. So any motion in a plane can be called as motion in two dimension. Motion in a plane is called motion in two dimension. Now let me explain motion in three dimension. Motion in three dimension. As the name implies, in this case, all the three coordinates of the body will change. When all the three coordinates change, then the motion is said to be motion in three dimension. Means when a body moves in such a way that x coordinate, y coordinate and z coordinate, all the three change, then the motion is said to be motion in three dimension. For example, when an aeroplane is moving in the sky, its all the three coordinates are continuously changing. So motion of an aeroplane in space can be called as motion in three dimensions. Similarly, motion of a kite in the sky can also be called as motion in three dimensions. That's all.